In this question, you're expected to write these two expressions as a single fraction in its simplest form. So basically, what you have to remember here is that if you have a fraction such like, for example, a over b plus c over d, basically what you can do is multiply a and d, so you have ad, and then multiply b and c, so bc, over multiply the denominators bd. So this is always true. So you can apply the same approach here to basically simplify these two fractions. So here we'll have 3 multiplied by x plus 3 plus 5 multiplied by x minus 2 over 5 multiplied by 3. So that simplifies to 3x plus 9 plus 5x minus 10 over 15. And this will simplify to 8x minus 1 over 15. And that's basically how you simplify that fraction. The second part of this question, uh, we are required to simplify this expression. So basically, this is indices, and what you have to remember here is that if you have a to power m to power n, that is same as a to power m multiplied by n. Okay, so multiplied by n. So these are just laws of indices. So here we have 8, everything to power third. So a to power a third, e to power 9 to power a third, and then e to power 6 to power a third. So something else that you have to also remember is that um, if you have something like, for example, um, a to power a third, that is same as the cube root of a. Again, that's something that you have to remember from laws of indices. So here, this is same as cube root of a. Now, multiply, here we have e to power 9 multiplied by a third. And then here we have, sorry, actually this was a, my apologies. So that's a to power 9. And this is then, here we have e to power 6 multiplied by a third. All right, so the cube root of 8 is just 2. A third of 9 is just 3, so that will be a to power 3. A third of 6 will be 2, so that will be e to power 2. So we'll have 2a cubed e squared. And that's how you simplify that expression. Okay, moving on to number 6. Again, here we are required to show that the left hand side is equal to that. So from the left hand side, I'll apply the same approach that I explained in the beginning of this video. So you multiply 3 times 15 plus 2 multiplied by 10. This is basically how you add fractions. 10 multiplied by 15. It's a simple approach. And this will be equal to 45 plus 20 over 150, which gives you 65 over 150. Now, these two numbers are multiples of 5, so you divide by 5, and you will end up with 13 over 30 as required. The same, it's just the same approach as what I explained in the beginning. Here, what you need to do first of all is to rewrite these fractions as improper fractions. You multiply here, you multiply 2 by 8 to get 16, and then you add 5. The same thing here, multiply and then add. So 2 multiplied by 8 will be 16. 16 plus 5, that will be 21. So 21 over 8 divided by 7 over 6. So this is from the left hand side again, from left hand side. Okay, so then there's something called keep, change, flip. It's a strategy on how to divide fractions. So keep that, change that, and then flip that. Okay, so keep, change, flip, probably something that you're taught in junior school. So that will be equal to 21 over 8. We change that to multiplication, and then we flip that. And then when you multiply fractions, you just multiply numerators and denominators, and that will give you basically the numerator will be 126, the denominator will be 56. Now each of these numbers is a multiple of 2 and also multiple of 7, so we can divide by 14, um, and you'll end up with 9 over 4 as required. Now 9 over 4 is same as 2 and a quarter, yeah, and that is basically what's required. You're required to show that, using the correct process, the left hand side is equal to the right hand side.